Right now, inside some of the largest companies on the planet, something is happening that almost nobody outside of engineering leadership is talking about. AI agents, not chatbots, not co-pilots, actual autonomous software agents are being deployed in teams. They're negotiating with each other, delegating tasks to each other, making decisions that used to require 3 layers of middle management. And here's the number that should make you sit up straight. Gartner predicts that by the end of this year, 2026, 40% of enterprise applications will embed AI agents. That's up from less than 5% just last year. But here's the part that should really get your attention. Over 40% of those agentic AI projects will be canceled or fail to reach production by 2027. 40% built, 40% failing. And in that gap between ambition and execution lives the biggest career opportunity and the biggest career threat of 2026.
Yeah, it really is just a staggering transition. I mean, we are essentially watching the operating system of the modern enterprise being completely rewritten in real time.
Right.
And honestly, those failure rates you just mentioned, they prove that most organizations are completely, almost tragically unprepared for it.
Well, welcome to the deep dive, everyone. We are staring down a massive stack of postmortems today. We've got enterprise research from Gartner, Forrester, IDC, and we're even looking at some raw technical blueprints from the Linux Foundation.
Which is where the real story is.
Exactly, because if you don't understand why these deployments are imploding, why they're failing so spectacularly, you are going to be a casualty of what they're now calling the orchestration economy. So our mission today is to cut through this absolute mountain of hype surrounding agentic AI.
And there is a lot of hype.
Oh, it's everywhere. And I'll be honest with you, looking at these numbers, I'm feeling deeply cynical today. I look at this tech hype cycle and I just see a direct existential threat to white-collar coordination jobs. And it's bundled with a failure rate that, honestly, would get any human manager fired on the spot. I mean, 40%. It feels like a massive corporate bubble just waiting to pop.
I completely understand that cynicism. I really do. It does look like a bubble if you only read the marketing copy, right?
Which is what most executives are doing.
True. But if you look at the underlying architecture, like the actual protocols being adopted right now, this is not a doomsday scenario. And it's definitely not vaporware.
Okay, so what is it then?
It's a messy, violent transitional period. Yes, the failure rates are catastrophically high, but that is because we are fundamentally moving from a paradigm of humans using tools to a completely new paradigm of autonomous systems collaborating with each other.
And that requires a totally different mindset.
Exactly. It requires a completely new set of tactical skills. If you understand the mechanics of how these multi-agent systems actually work, and more importantly, why they break down and burn through budgets, you can navigate this transition. You can actually position yourself to be the person who rescues these failing projects.
I want to believe that, I really do. But let's ground this in the sheer scale of what we're talking about, because the market shift here is just, that's hard to wrap my head around. The agentic AI market is moving from roughly $7 to $8 billion in 2025 to a projected $52.62 billion by 2030.
Yeah, that's a 46.3% compound annual growth rate. It's massive.
It's explosive. And Gartner has mapped this out into 5 distinct stages of evolution. They say we are currently entering stage 2. That means task-specific agents are being embedded in 40% of apps by the end of this year.
Right, which means they are already looking towards stage 3.
Which is collaborative ecosystems, right? Like agents working with other agents.
Exactly.
But right in the middle of our sources is this massive red flag. They're calling it the pilot to production death valley.
Oh yeah, the death valley.
It's brutal. 65% of enterprises are running pilots right now. They're basically playing in the sandbox. But only 11% actually reach production. That is a 54-point gap of pure, unadulterated failure. I mean, why is everyone crashing their cars before they even get on the highway?
Well, to understand the crash, you really have to look at the fundamental difference between what these executives think they are buying and what they actually need to build.
Okay, break that down for me.
So go back just a year or two to like 2024 and 2025. The entire focus of the industry was on single agent systems. You had one massive generalized AI model, basically the digital equivalent of an overwhelmed genius, and you tried to make it do everything sequentially in one giant prompt.
Right, like write the code, test the code, deploy the code all at once.
Exactly. Or, read the angry customer email, check the inventory database, cross-reference the refund policy, and write the response.
The ultimate generalist.
Right. But single-purpose generalized agents are already considered totally outdated architecture. They create this massive cognitive bottleneck.
How?
Well, If you give a generalist agent a complex, multi-step workflow, its context window just gets bloated. It gets confused, it loses the plot halfway through the task, and it inevitably hallucinates.
So it forgets what it was doing.
Pretty much.
Yeah.
What we are seeing now, and the shift driving that $52 billion market, is the move to multi-agent systems. This is what they call swarm intelligence.
Swarm intelligence, okay.
Yeah. So instead of one overwhelmed genius, you have highly specialized, narrowly focused agents operating in parallel.
Give me an example of that.
So one agent only does web research. It is expert at nothing else. Another agent only does legal compliance checking. Another only drafts emails. They route tasks between themselves. They analyze data collectively. And critically, they review and self-correct each other's work before a human ever even sees it.
Okay, so instead of one guy trying to run the entire company from a single desk, it's a specialized team of digital workers.
That's the idea, yeah.
I mean, that sounds incredibly efficient on paper. So why the 54-point failure gap? Why the death alley?
Because building a coordinated team of autonomous software agents and getting them to actually communicate without spiraling into an infinite loop of errors is infinitely harder than just building a single chatbot.
Right.
And this brings us to a pervasive disease in the enterprise software market right now. The industry is calling it agent washing.
Oh man, agent washing. I was reading the By Yoda report in our stack, and the numbers here just blew my mind. Out of the thousands of vendors currently banging on CIOs' doors claiming to sell enterprise-grade agentic AI, Gartner estimates only about 130 of them are actually selling legitimate autonomous agents.
Yeah, just 130.
The rest are completely faking it. They are just rebranding basic old-school chatbots or robotic process automation RPA tools.
All marketing.
It reminds me exactly of the dot-com bubble. You know, when companies just slapped a .com on their corporate letterhead to double their stock price. Or food companies slapping an organic label on a candy bar. If only 130 vendors are real, how on earth is the listener supposed to spot the fakes? Like, how do I tell my boss that the multi-million-dollar agent software they just bought is actually just a glorified script from 2018?
It is a massive problem, and frankly, it is the hidden culprit behind a lot of those failed pilots in the Death Valley.
Because they bought fake agents.
Exactly. Executives buy what they think is an autonomous reasoning agent, but it's really just a static, brittle, if-then script wrapped up in a slick new user interface.
So how do we spot them?
To spot the fakes, you have to bypass the marketing pitch entirely. You need to apply a rigorous 4-question test to any vendor claiming to sell agentic AI.
Okay, I love a good framework. Break this test down for me, and don't just give me the high-level bullet points. I want to know exactly how to grill a vendor on this.
All right, question 1. Does it take initiative?
Meaning what?
A real agent doesn't just sit there idly waiting for a human prompt. It acts based on an overarching context and a persistent goal. Let's say the goal is keep inventory above minimum levels.
Okay.
A real agent will monitor the database, notice a dip, proactively research supplier pricing, and draft a purchase order without you asking. If the software only does something when you hit enter, it's not an agent. It's a chatbot with a massive marketing budget.
So it has to have an autonomous loop. It has to wake up in the morning and go to work without me telling it to.
Exactly.
I like that. What's question 2?
Question 2. Can it handle multi-step workflows with ambiguous routing?
Ambiguous routing.
Yeah. Single-step command following is just basic automation. Like, if an email arrives from client A, put it in folder B. That's not an agent. An agent needs to make dynamic decisions at multiple stages of a process where the path isn't perfectly clear.
Oh, and things go wrong.
Right. If it encounters a corrupted file in step 2, does it just crash? Or does it autonomously decide to search for a backup file, run a repair script, and then continue to step 3?
It has to handle the messy reality of work, not just the happy path where everything goes perfectly. Got it. Okay, what's question 3?
Does it learn and improve its own decision-making?
So, memory.
True autonomous agents adapt their workflows. If an agent tries a specific negotiation tactic with a supplier via email and it fails 3 times, does the agent update its internal memory to try a different approach next time?
Whereas a script wouldn't.
Exactly. Static rule-based systems do not learn. They will fail the exact same way a million times in a row. An agent updates its own behavioral parameters based on historical outcomes.
Right. And question 4.
Can it integrate across systems seamlessly? If it only works inside its own proprietary silo, like if it can only read documents uploaded into its specific dashboard, you are buying a confined tool. You are not buying an autonomous agent.
It has to be able to reach out.
An agent needs to traverse the enterprise. It needs to check Salesforce, then jump into the SQL database, then ping a Slack channel.
That fourth question seems like the absolute linchpin to me. Because let's say you navigate the minefield. You find one of the 130 real vendors. You buy a legitimate, initiative-taking, self-correcting agent. It's brilliant,
Right.
but it can't actually do anything if it can't talk to the rest of the company's software. Or, more importantly for stage 3, if it can't talk to the other agents from other vendors.
Which is exactly the bottleneck we've had for the last 2 years.
Which brings us to the underlying plumbing making this all possible. We are experiencing what the sources repeatedly call the HTTP moment for AI.
I really think that is the perfect analogy. Think about the early internet before the HTTP protocol was universally adopted. It was just a fractured, useless mess of proprietary networks. America Online couldn't easily talk to CompuServe.
Right, walled gardens.
We've had the exact same problem with AI agents recently. You had an amazing OpenAI agent, but it was trapped in a box. You had a brilliant Anthropic agent trapped in a different box.
And they couldn't coordinate.
Not at all. But right now, we are seeing the emergence of 2 dominant open source protocols under the governance of the Linux Foundation. These aren't products. They are foundational rules of communication.
Okay, we need to spend some serious time here because this is the foundational architecture our listener needs to understand if they want to survive this transition.
Definitely.
We have 2 acronyms to learn here. MCP, which is the Model Context Protocol created by Anthropic, and A2A, the Agent-to-Agent Protocol spearheaded by Google. Both are now open source.
Yes, and that open source part is vital.
Let's start with MCP. The sources call this the USB-C for AI. It currently has over 97 million monthly SDK downloads, which is an absurd speed of adoption. How does MCP actually work on a mechanical level?
So think of MCP as vertical integration. It handles the communication between an AI agent and an enterprise tool.
Yeah.
Let's go back to before MCP existed, say early 2024. If you wanted your AI agent to query your secure internal SQL database or check a Jira ticket board or pull a PDF from a private Google Drive.
Basically any normal corporate task.
Exactly. Your software engineers had to write custom, brittle API integrations for every single connection. If you have 5 different AI models and you want them to connect to 50 different enterprise tools, you have a massive problem.
Right, the sources call that quadratic complexity.
Exactly. The math just gets completely out of hand. Every new model needs a custom link to every new tool. It's a maintenance nightmare. If Jira updates their API, all your custom agent links break instantly.
Ouch.
But with MCP, that quadratic complexity is eliminated overnight. It uses a standard client-server architecture. The AI model runs an MCP client, and your enterprise tools are exposed via an MCP server.
Wait, hold up. Let's translate this. If I'm a logistics manager or an HR director listening to this, my eyes just glazed over at the phrase client-server architecture. What does that actually mean in plain English?
Fair point.
Yeah.
Fair point. Think of MCP like a universal translator plug. The MCP server acts as a standardized wrapper around your databases and tools. So the AI agent doesn't need to know the specific, complicated language of Jira or the specific query language of your secure SQL database. The agent just speaks MCP.
It just uses the universal plug.
Right. It asks the MCP server, hey, what tools do you have available? The MCP server dynamically responds with a standardized list of capabilities. Then the agent says, great, use tool number 3 to fetch this user's data.
That makes sense.
MCP standardizes all the resource schemas, usually communicating via something called JSON RPC 2.0 messages.
Okay, you did it again. JSON RPC 2.0 messages. Break that down for me.
Sorry, right. So think of JSON RPC like a standard digital envelope. Before, every enterprise tool required a custom-sized envelope with the address written in a completely different language. If you didn't use the exact right envelope, the tool rejected the request.
So it's just a mess of custom envelopes.
Yes. JSON RPC is an agreement that every single agent and every single tool will use the exact same standard envelope. It's really just a lightweight text format that says, here's the method I want to run and here are the parameters. Because everyone agrees on the shape of the envelope, the agent can securely connect to databases without any custom coding.
Okay, I like a corporate physical analogy. Let me try this. So MCP is basically giving the AI agent a universal key card to the corporate file room in the server room. It gives them the context, the data, the tools. They can swipe into any database that has an MCP server running.
That's a great way to put it.
But that's just vertical. That's just one agent talking to a dumb database. What about when we need swarm intelligence? What about the other acronym, A2A?
Right. So if MCP is vertical tool use, A2A is horizontal coordination. A2A, which stands for agent-to-agent, is the protocol that allows opaque, black box agents from completely different vendors to collaborate with each other.
Meaning they don't have to be built by the same company.
Exactly. Let's say your company has an inventory agent built on OpenAI's framework and an ordering agent built on Google's framework. They don't share a brain. They don't know how the other one thinks, but they need to work together to restock a warehouse. A2A provides the standard language for them to discover each other on the network, negotiate tasks, and share results.
So to extend my analogy, if MCP is the universal keycard to the file room, A2A is giving the agent the company directory, a telephone, and a Slack channel so they can actually call up other departments and delegate the work.
Exactly. And the technical mechanics of how A2A allows them to call each other up are really brilliant. It relies on something called agent cards.
Agent cards?
Yeah. Think of an agent card as a JSON-formatted resume. When an agent boots up and enters the corporate network, it publishes its agent card. This card details its exact capabilities, the inputs it requires, the outputs it produces, and its authentication needs.
So it's literally raising its hand and saying, hi, I'm the legal compliance agent. I need a PDF as an input, and I output a risk score from 1 to 10.
Precisely. So when a procurement agent is drafting a contract, it can search the network, read that agent card, and say, I need a legal document reviewed, and this card says it specializes in compliance. Let me route this task over there.
That is wild.
But A2A also solves a massive timing problem. See, some AI tasks take milliseconds, like classifying an email. Other tasks take days, like an agent being asked to research a massive data set of a competitor's pricing history. A2A handles both of those seamlessly.
How? I mean, if one agent delegates a 3-day research task to another agent, doesn't the first agent just sit there frozen, burning compute time while it waits for the answer?
Not with A2A. The protocol uses 2 different mechanisms depending on the time frame. For real-time, fast tasks, it uses server-sent events or SSE.
Wait, hold on. You're going to have to translate SSE for me. What does that actually mean?
Sure, SSE is like an open phone line. The procurement agent calls the legal agent, keeps the phone off the hook, and the legal agent streams its thoughts back in real time over the open line. It's a continuous open connection.
Okay. That makes sense for fast stuff.
Right. But for a task that might take a week, keeping the phone off the hook is a massive waste of resources. So for long tasks, A2A uses asynchronous push notifications via webhooks.
Meaning what? Like voicemail?
It's exactly like voicemail. The procurement agent drops off the massive file, leaves a webhook address, essentially its callback number, and says, I'm going to go do other things. When you finish analyzing this in 3 days, call this number and leave the results.
Oh, wow.
Yeah, so the first agent is freed up to do other work entirely.
You know, there is an auto repair shop analogy in the A2A documentation that really cemented this whole architecture for me. MCP connects the mechanics, the AI agents, to the wrenches, the diagnostic machines, the parts database. That's agent to tool. A2A is the protocol that lets the mechanics actually talk to each other to figure out who is fixing the transmission and who is rotating the tires.
Exactly. I mean, it's the perfect way to visualize it.
And here's where my cynicism flares right back up, because this all sounds beautiful on a whiteboard.
Right.
But let's look at an executive procurement example in the real world. Let's say an agent from sales uses A2A to ask an agent from legal to review a multi-million-dollar vendor contract. What happens when the legal agent hallucinates? What happens when it confidently misinterprets a massive liability clause? If these agents are operating autonomously, passing JSON RPC envelopes back and forth at machine speed using server-sent events, doesn't a single hallucination just trigger a massive, high-speed, invisible disaster?
You have just put your finger on the exact reason why Gartner is predicting that 40% failure rate.
Really?
Yes. When you chain autonomous agents together using these protocols, you introduce a terrifying vulnerability called cascading failures.
Cascading failures.
If the legal agent hallucinates and passes that flawed, hallucinated output back to the procurement agent via an A2A webhook, the procurement agent has absolutely no idea it's a hallucination. It just assumes the legal review is rock solid.
Oh, no.
It incorporates that bad data, signs the contract, and pushes it to the finance agent for payment. A single error at the start of the chain amplifies exponentially as it moves through the swarm. This is the dark side of multi-agent orchestration, and it's why the industry is currently hitting a brick wall.
Right. And that wall is what we need to look at dead on, because our sources break down that 40% failure rate into 5 specific catastrophic reasons. Let's walk through them, because this is where the theoretical hype hits the incredibly expensive pavement.
Let's go.
Reason number 1 for multi-agent pilot failure: costs exploding from pilot to production.
This is the most immediate, visceral shock for organizations, and honestly, it gets CIOs fired.
Mm-hmm.
You run a pilot with a few agents in a sandbox. You give them a toy problem to solve. It works beautifully, and the API tokens cost you $50 for the week.
Everyone's happy.
Right. You take that success to the board, you get approval, and you roll this multi-agent swarm out to the entire enterprise to handle live customer data. Suddenly, your AWS or Azure bill arrives at the end of the month, and instead of $50, it is $90,000.
I need you to explain the math on that. How does $50 turn into 90 grand in 30 days?
Because of the coordination tax, which is actually the second reason these projects fail.
Okay, the coordination tax.
Multi-agent systems promise efficiency through specialization, but coordinating them is computationally brutal. Think about how agents actually operate under the hood. They reason, they plan, they talk to each other, they review work, and critically, they retry when they fail.
Okay.
Every single time an agent thinks, every time it generates a thought process or reads another agent's output, it consumes tokens.
And tokens cost money.
Exactly. When you have a swarm of agents constantly communicating via A2A, constantly polling MCP servers to check database status, and constantly critiquing each other's work, the token burn rate becomes astronomical.
So they're just chatting up a storm and billing you for it.
Exactly. Let's say Agent A asks Agent B for data. Agent B misunderstands the request and sends the wrong data. Agent A has to burn tokens to read the bad data, burn tokens to realize it's wrong, burn tokens to draft a correction prompt, and send it back to Agent B, who then burns more tokens to try again. You aren't just paying for the final polished output. You are paying a premium for every internal conversation, argument, and iteration the agents have with each other in the dark.
That makes total sense. It's like paying an hourly consulting wage to 5 different experts to sit in a conference room for 3 days, arguing about how to format a single email. The overhead is ridiculous.
Yep.
Which brings us directly to the third reason for failure: observability black boxes.
Right. And this ties directly back to that $90,000 bill.
Mm-hmm.
When a traditional deterministic software application fails, you get an error log. You can trace the stack trace to exactly which line of Python code broke.
Right, it's predictable.
But multi-agent systems are non-deterministic. They make decisions on the fly. If a massive 15-step workflow fails, or if it burns through $10,000 of tokens in an hour, it's incredibly difficult to know why.
Because it's a black box.
Exactly. Did the sales agent give a bad instruction? Did the legal agent misinterpret it? Did the MCP server return corrupt SQL data that confused the swarm? Without enterprise-grade observability tools specifically designed for AI telemetry tools that track the actual thought process of every agent, the entire system becomes an opaque black box. You literally cannot fix what you cannot see.
And when you can't see what they're doing, you get the fourth reason for failure, which is frankly the one that terrifies me the most.
Yeah.
Our sources state that 80% of companies running multi-agent pilots report agents acting outside their established boundaries. 80%.
Huge number.
That means unauthorized access to data or taking actions they were absolutely not approved to take.
This is a fundamental architectural governance failure. Agents, by definition, are designed to aggressively pursue a goal. If you tell an autonomous customer service agent, your overarching goal is to resolve this customer's complaint and achieve a 5-star rating, and you haven't strictly mathematically bounded its authority,
It's going to do whatever it takes.
it will find the fastest path to that goal. It might decide the most efficient way to resolve a complaint about a delayed $20 shipping fee is to autonomously issue a $10,000 refund to the customer.
Wow. Are you serious?
Yes, it achieved the goal. The customer is thrilled. 5 stars. But it catastrophically violated business policy because the boundaries weren't set. It will use any tool available via MCP to achieve its objective unless it is explicitly blocked.
Which perfectly sets up the fifth reason for failure. Legacy systems are fundamentally misaligned with agent autonomy. You can't just drop an autonomous swarm into a bureaucratic 7-step email chain workflow and expect magic.
What's fascinating and deeply frustrating here is how often companies get this entirely backward.
Yeah.
They have a broken, highly manual, undocumented internal process.
We all know those processes.
Right. Let's say it's employee onboarding. It involves 3 different departments, 5 spreadsheets, and a bunch of verbal agreements. And leadership thinks, this process is a nightmare. Let's just buy an AI agent swarm to fix it.
Slap some AI on it.
Exactly. But automating a broken process just makes a faster nightmare. Legacy corporate systems were built under the assumption that a human would be sitting at the keyboard, reading the screen, interpreting the unwritten nuance, and making a judgment call at every messy step. AI agents cannot do that.
They need structure.
They need structured data, clear APIs, and logical binary rule sets. If you force an A2A agent swarm to navigate a messy, human-centric bureaucracy with undocumented exceptions, it will fail 100% of the time.
You know, I want to highlight a statistical reality from the sources called the multiplication problem, because this really exposes the house of cards for me. Let's say I have a single state-of-the-art AI agent, and it is incredibly good. It is 95% reliable. That sounds fantastic. 95 out of 100 requests succeed flawlessly.
Sounds great on paper.
But if I use A2A to chain 5 of those agents together in a sequential workflow, say intake, research, drafting, legal review, and set...
Reliabilities multiply.
Right. It's basic probability. 0.95 times 0.95, 5 times. By the time you string 5 highly reliable 95% agents together, your overall system reliability drops to 77%.
It's a huge drop.
Almost a quarter of your enterprise workflows are now failing, hallucinating, or requiring emergency human intervention. If chaining 5 agents drops my success rate to 77%, and my pilot bill jumps from $50 to $90,000 a month, and the agents are hallucinating $10,000 refunds, I mean, why wouldn't a rational CFO just cancel this program immediately?
Well, many of them do. That is exactly the driving force behind that 40% cancellation projection.
Yeah.
And you have to understand, the costs aren't just the direct API bills.
Right, there's fallout.
The Software report in our stack outlines the hidden opportunity costs of a failed enterprise deployment. When you factor in the engineering hours spent building custom MCP servers, the time spent debugging the black box, and the disruption to the business, a failed enterprise multi-agent system can cost a mid-sized company upwards of $600,000.
Over $500,000 for a failed pilot.
But honestly, it's not even just the money. It's the strategic setback. It's the absolute demoralization of your engineering team and the total loss of stakeholder trust. Once a CFO sees an agent issue a hallucinated refund, they will never trust the system again.
It's no wonder the data shows that currently only 6% of companies fully trust AI agents for core business processes. 6%. We are even seeing the federal government react to this chaos.
Yes, the NIST report.
Right. There is a NIST request for information, an RFI, specifically seeking input from the industry on the security considerations for AI agents. The federal government is scrambling to figure out how to secure these autonomous systems against backdoor attacks, malicious prompt injections, and these cascading A2A failures we just talked about. The government is basically waving a massive red flag, saying, how do we secure enterprise networks against systems that can think and act on their own?
It's a critical RFI, and it highlights that the risks we are discussing are recognized at the very highest levels. But, and this is where we have to pivot from the realism to the tactical opportunity.
Okay, hit me.
If 40% fail, that means 60% succeed.
That's the flip side.
And the 60% that survive the Death Valley are not getting lucky. They succeed because they aren't treating AI agents like a plug-and-play software installation. They are treating multi-agent orchestration as a complex systems engineering challenge. They're using highly specific architectural frameworks and rigorous governance models to tame the chaos.
Okay, let's pivot to the solutions then. We need to talk about building the right way. We need to talk about frameworks, governance, and real ROI. If I'm an enterprise trying to deploy a multi-agent swarm without setting my budget on fire, what am I actually using to build the control layer?
You're using an orchestration framework. This is the absolute critical piece. You do not just let agents loose on an A2A network and hope for the best.
No free-range agents.
Exactly. The orchestration framework is the control layer that manages the agents, handles the state of the workflow, and ruthlessly enforces the rules. Right now, there are 3 dominant frameworks that any organization needs to understand: LangGraph, Crew AI, and Autogen.
Let's break those down. If I'm leading a deployment, when do I use which one?
So LangGraph is currently the gold standard for stateful, complex, production-grade control. It is built entirely around the mathematical concept of graphs, specifically nodes and edges. It gives you explicit, rigid control flow over the swarm.
Okay, define nodes and edges for me in this context. How does that actually control the swarm?
Think of a node as a checkpoint or a specific task. Agent A, draft the email. The edge is the routing logic. If the email contains financial data, route to node B for compliance. If it does not, route to node C for sending.
So it's very structured.
Very. LangGraph maintains this state, meaning it remembers everything that has happened up to that exact microsecond. If you are building a mission-critical enterprise pipeline where you absolutely need checkpoints, error recovery loops, and strict deterministic routing logic so the agents can't just go rogue, LangGraph is your best bet. It is highly engineered.
But I assume that comes with a steep learning curve for the engineering team.
Yes, very steep. It requires a deep understanding of graph theory and state management.
Okay, what about the second one, Crew AI?
Now, if you want rapid prototyping, or if the problem is less rigid, you look at Crew AI. Crew AI is brilliant because it is entirely role-based. You literally define your AI agents like a movie crew or a corporate department.
How does that look in practice?
You write prompts that say, you are the senior market researcher. Your goal is to find 3 competitors. You are the copywriter. Your goal is to summarize the researcher's findings.
So it's much more like managing virtual employees.
Exactly. It's fantastic for setting up collaborative teams quickly, and it's much more intuitive for non-engineers to understand. However, because it relies more on the agents organically talking to each other rather than rigid graph logic, it offers slightly less granular, deterministic control than LangGraph.
Got it. And what about AutoGen? That's the one out of Microsoft Research, right?
Correct. AutoGen is optimized for conversational and highly autonomous agents, particularly around writing and executing code. It's heavily focused on setting up environments where agents talk to each other, write code, run the code in a secure sandbox, critique the errors, and debug it collaboratively.
So it's for heavy lifting.
It is excellent for research-heavy tasks or complex math scenarios where you want agents to collaboratively solve a problem through dialogue rather than following a rigid pipeline.
So to summarize the toolbox, LangGraph for rigid, stateful production pipelines where you can't afford a mistake, Crew AI for rapid, role-based, collaborative teams, and AutoGen for conversational problem-solving and coding.
You got it.
But here's the thing. Even at the perfect framework, you still have the governance problem we talked about, the 80% of agents going out of bounds. The sources talk heavily about a mandated shift to governance-first design and something called the agentic operating system. What does that actually mean in practice for a company?
It means you engineer the guardrails before you engineer the autonomy, period. An agentic operating system provides 3 fundamental pillars, which are orchestration, which is what LangGraph does, coordinating the handoffs. Adaptability, meaning you can swap out an OpenAI model for an Anthropic model without breaking the system. And critically, governance. In practice, governance-first design means implementing defense-in-depth and human-in-the-loop safeguards at the architectural level.
Give me a concrete example of that. How do I actually stop the agent from hallucinating a $10,000 refund?
You implement a cryptographic boundary. You don't just give an agent access to your corporate email server and the Stripe payment API and say, handle customer complaints.
That'd be a disaster.
Right. Instead, you give the agent permission via MCP to draft the response and propose the refund.
Yep.
But you architect the system so that the agent physically, cryptographically, cannot execute the final API call to Stripe until a human manager clicks approve in a dashboard. Or you define strict programmatic financial boundaries. The agent is fully autonomous to issue refunds, but the MCP server is hard-coded to reject any request over $50. Anything above $50 triggers an A2A escalation to a human supervisor's queue. You bound the autonomy mathematically.
And when you successfully bound the autonomy like that and you use the right orchestration framework, the ROI is undeniably massive. Let's look at some of the success stories in our stack because these are the 60% that survive. Walmart is a prime example here.
Great example.
They deployed an AI super agent that ingests massive disparate data sets, point-of-sale data, local weather forecasts, web traffic trends, and supply chain inputs. It autonomously forecasts demand per store. They saw a 22% increase in e-commerce sales in their pilot regions.
22% is huge at Walmart scale.
Massive banks are using agentic workflows for KYC Know Your Customer and anti-money laundering compliance. And they are reporting 200 to 2,000% productivity gains in document review. Ramp deployed a finance agent that reads complex company policies and autonomously audits employee expenses, reducing manual human expense reviews by 60%.
Those numbers are very real, and they are exactly why companies are willing to risk the 40% failure rate and the $90,000 AWS bills. But notice what every single one of those successes has in common.
They're specific.
Exactly. They are highly specific, deeply domain-bounded tasks. Walmart didn't build a general run-the-store agent. They built a highly specific demand forecasting and restocking agent swarm. Ramp didn't build a CFO agent. They built an expense auditing agent. Focus is how you survive.
You know, there's another trend buried in the sources here that caught my eye, and it feels like a double-edged sword to me. The rise of visual, no-code, and low-code orchestration platforms like Jojit.
Oh, this is a heated topic.
I bet. The argument in the white papers is that you should allow business users, the HR managers, the logistics coordinators, the people who actually understand the messy, broken processes, to build the AI agents themselves using drag and drop interfaces, totally bypassing the IT department bottlenecks.
Right.
But I have to push back on the practicality of this. You're telling me a non-technical HR manager is going to use a drag and drop tool to build a multi-agent A2A swarm? Doesn't that just create a massive shadow AI problem where the IT department has absolutely no idea what rogue, hallucinating agents are running around the corporate network, reading sensitive employee salary data?
That is the exact tension tearing enterprise IT departments apart right now. It really is. Because if IT insists on building everything themselves using LangGraph, it takes 2 years, it's over budget, and by the time it's deployed, it doesn't even fit the business need anymore.
Because they don't know the business process.
Exactly. But if business users build everything themselves with no oversight, you get shadow AI, massive security breaches, and that 40% failure rate skyrockets. The solution, and what platforms like GoJet aim to do architecturally, is provide a governed, IT-controlled sandbox.
How does a sandbox solve it, though?
IT sets up the foundational plumbing. IT configures the MCP connections, defining exactly which databases and APIs are safe to access. IT establishes the A2A boundaries and the token spend limits. Then, they hand that secure, pre-configured sandbox to the HR manager.
Ah, I see.
The HR manager uses the visual builder to drag and drop the logic of the workflow. The HR manager knows how the process should work. They know who needs to approve what. They design the swarm's behavior. But the platform ensures the agents physically cannot violate IT's underlying security policies or exceed the budget while doing it.
Okay, I got it. So it's like giving someone a box of Legos to build whatever castle they want, but you control exactly what color and shape the Legos are, and you specifically don't give them any pieces that can burn down the house.
Precisely. And when you empower the domain experts with safe tools, we are seeing amazing use cases emerge. Genentech is a great example.
What are they doing?
They built agent ecosystems on AWS, specifically for drug discovery. The highly paid human scientists focus entirely on the creative breakthroughs and hypothesis generation, while a swarm of agents handle the mind-numbing data processing, literature reviews, and cross-referencing of millions of chemical compounds.
Freeing up the humans to actually think.
Right. Or take internal IT support. Instead of a human help desk worker manually resetting passwords all day, an IT triage agent analyzes the incoming ticket. If it recognizes a password issue, it uses A2A to autonomously spawn a specific temporary password reset bot to guide the user through the process, entirely bypassing the human queue.
Okay, but this realization that these agents are literally taking over project management, IT triage, QA, and workflow routing leads us directly into the most critical and honestly most sobering part of this deep dive.
The job market.
Exactly. Let's talk about career impact, how to survive the orchestration economy. Let's start with the blunt truth from the sources because we cannot sugarcoat this for the listener. Orchestration architecture replaces human coordination work.
Yes, it does.
If your current job description involves task routing, multi-source data compilation, quality assurance, or taking an issue from Team A and escalating it to Team B, you are squarely in the crosshairs. The orchestration layer is architecturally replacing you.
It is a harsh reality, but it is undeniable. For decades, the primary role of massive swaths of middle management has been pure coordination, passing information from sales to legal, ensuring compliance documents are attached, tracking the status of a project in a spreadsheet.
Human routers.
Exactly. And A2A protocol doesn't just assist with that coordination, it replaces the need for it entirely. Machines coordinating with machines is frictionless. Humans coordinating with humans is expensive friction.
The projections are jarring. Palo Alto Networks projected that by 2026, we will see an 82-to-1 autonomous agent-to-human ratio, 82 active digital agents for every human employee on the network. That is a total ground-up restructuring of the workforce. If your job is just passing information, an A2A protocol will do it faster, cheaper, and at 3 a.m.
It's inevitable.
But the expert view in our sources is that the 40% failure rate, the sheer difficulty of making this actually work, is creating a massive vacuum for new jobs. Our sources identify 4 specific emerging roles. Let's go through them deeply because this is the survival guide. First emerging role, agent architect.
So the agent architect is the visionary who designs the multi-agent system. They understand the art of task decomposition. They look at a massive, messy business problem like supply chain optimization and decide, we can't use one agent for this. We need 3 specialized agents. We need to use LangGraph to enforce state. Agent A will use MCP to check inventory. Agent B will use A2A to negotiate with the supplier.
So they designed the blueprint.
They designed the graph. It requires deep systems thinking. Interestingly, if you have a background in traditional distributed systems, microservices architecture, or site reliability engineering SRE, your skills map perfectly to this. You are just routing AI models instead of database queries.
Okay. Second role, agent ops engineer.
This is the operational, boots-on-the-ground side. Once the agent architect deploys the swarm, someone has to monitor it. The agent ops engineer lives in the observability dashboard. They track the token costs daily to ensure the swarm isn't burning the departmental budget on an infinite loop.
Keeping an eye on the $90,000 bills.
Exactly. They monitor for cascading A2A failures, API latency spikes, and hallucination rates. It is DevOps, but specifically tailored for non-deterministic autonomous swarms.
Third role, AI governance specialist.
As we discussed, 80% of companies have agents going rogue. The governance specialist is the person who stops that. They create the oversight frameworks, they define the strict security boundaries, they manage the human-in-the-loop escalation paths, and they ensure the agents comply with sweeping regulations like the EU AI Act or internal corporate data privacy rules.
Here are the brakes.
They are the brakes that allow the sports car to go fast without flying off the cliff.
And the fourth role, which sounds the most accessible to non-engineers, the human-AI collaboration designer, or what the industry is brilliantly calling the agent boss.
I love that title because it perfectly describes the future of management. The agent boss is the human who manages the swarm like a team of direct reports. They design the workflows between the human employees and the AI agents.
Okay, so managing digital labor.
Yes. They handle the complex, creative prompting to set the swarm's goals. And crucially, they solve the novel, unpredictable exceptions that the swarm escalates. When the agents hit a wall they can't navigate, a supplier refuses to negotiate, or a dataset is missing, the agent boss steps in, makes a strategic human decision, and guides the swarm back on track.
Okay, I have to ask the hard question here. I look at these 4 roles, architect, agent ops, governance, agent boss, and they're all highly senior, highly strategic, complex positions.
They are.
But if Palo Alto Networks says there will be 82 agents for every 1 human, what happens to the entry-level jobs? If AI swarms were doing all the junior-level analysis, writing all the first drafts, reading the thousands of legal precedents, and doing the basic QA, how does a 22-year-old ever get the foundational experience required to eventually become an agent architect or an agent boss? Are we just sawing off the bottom rung of the career ladder entirely?
That is perhaps the most profound organizational challenge of this decade, and honestly, the enterprise world does not have a perfect answer yet.
It's scary.
You are absolutely right. Traditionally, you learn the nuances of a business by doing the grueling grunt work. You learn legal strategy by reading thousands of boring contracts. If agents read the contracts, how do you train a junior lawyer?
Exactly.
What forward-thinking companies are starting to do is entirely shift the nature of junior roles from manual production to review and steering. A junior financial analyst might not build the Excel model from scratch anymore. Instead, from day one, they act as a junior agent boss.
Interesting.
They prompt the financial swarm, review the outputs, learn how to spot the AI's subtle hallucinations, and refine the logic. They were learning to manage and critique digital labor from their very first day, rather than learning to do the manual labor themselves. The foundational skill shifts from execution to critical evaluation.
That makes sense, but it's a massive paradigm shift in how we think about entry-level talent and education. Which brings us to the lifeline for our listener today. Having laid out the stakes, the catastrophic failure rates, the protocol plumbing, and the new roles, we need a concrete plan. How does the listener adapt immediately, regardless of their current technical expertise?
You have a plan.
The sources outline a specific, highly tactical 4-week plan. Week 1, build a 2-agent workflow.
Exactly. You cannot understand swarm intelligence conceptually by just listening to us talk about it. You have to feel it. In week 1, you don't need to be a programmer. Use a low-code tool like Crew AI or a visual builder like AnyDen.
What do you do with it?
Your goal is simply to build a tiny, toy 2-agent workflow. Make Agent A a researcher and Agent B a writer. Give them a topic and watch how they interact. Watch how Agent A gathers data, formulates it, and passes it to Agent B. See what happens when Agent B asks for clarification. This breaks the intimidating mystique of swarm intelligence down into tangible, understandable components.
Week 2, Study the plumbing, learn MCP and A2A.
Again, you do not need to be able to write the underlying Python code for these protocols, but you absolutely must understand how they work architecturally. Read the documentation for Anthropic's Model Context Protocol. Read Google's agent-to-agent protocol specs.
Why is that so important?
Because you need to understand the fundamental difference between connecting an agent to a dumb database MCP and having two autonomous agents negotiate a complex task A2A. Understanding this architecture is what separates the middle managers who get replaced by agents from the strategic leaders who architect the systems.
Week 3, audit your own role through the orchestration lens.
This is where it gets highly personal and slightly uncomfortable. Look at your daily tasks. What pure coordination work do you do? Who do you pass information to? What formatting or QA do you perform?
You have to be honest with yourself.
Ruthlessly honest. Be honest about which of your tasks an A2A-enabled swarm could do better, faster, and cheaper. Once you identify the vulnerable, rote parts of your job, you can figure out how to elevate yourself above them.
Let's make this incredibly concrete. Let's walk through a highly detailed scenario. Let's say I'm a logistics operations manager listening to this deep dive. Okay, week 1, I go home and I build a toy workflow in Crew AI. Week 2, I read up on A2A and JSON RPC. Week 3, I sit down with my coffee, I audit my job, and I realize a terrifying truth.
Let's hear it.
70% of my day is literally just opening emails, downloading exception reports about delayed shipments, checking an inventory portal, and drafting Slack messages to the warehouse to reroute trucks. I am a human A2A router. How do I map my messy, human-driven job into something algorithmic without just handing my CFO a blueprint for my own termination?
You survive by executing week 4 perfectly. Week 4 is pitch an orchestration pilot to leadership.
Pitch my own replacement.
No, you do not go to your boss and say, hey, I realize a bot can do 70% of my job. You go to your boss and say, I've been analyzing our operational efficiency. I've identified that our exception routing process is a massive bottleneck costing us time and money.
Right.
I've mapped out exactly how a small multi-agent swarm using Crew AI and MCP connections to our inventory portal could autonomously automate 70% of this routing.
Okay, I am pitching the efficiency.
But, and this is the absolute crucial part where you secure your job, you pair that efficiency pitch with the governance risks. You bring up the 40% failure rate. You tell your CFO about the dangers of cascading errors, unauthorized boundaries, and out-of-control token burn.
Show them the scary stuff.
You explain that without rigorous oversight, an A2A swarm could mistakenly reroute an entire fleet of trucks to the wrong state. And then you position yourself as the necessary agent boss. You say, I know the logistics domain better than anyone. I need to oversee this pilot. I will set the boundaries. I will monitor the observability metrics, and I will handle the complex exceptions the swarm can't process.
That is brilliant.
You stop being the human router, and you elevate yourself to the strategic leader managing the digital workforce.
You bring the poison and the antidote at the exact same time. You show them the massive ROI potential, the $52 billion market efficiency. But you make it crystal clear that without your human-in-the-loop oversight, they will end up as a Gartner failure statistic with a $90,000 AWS bill. That is incredibly tactical.
Knowledge is only valuable when it's applied tactically. If you understand the orchestration gap and you understand the protocols, you aren't a victim of this transition, you are the architect of it.
So let's bring this all together. We are witnessing a tectonic, irreversible shift from single, isolated chatbots to multi-agent autonomous teams. The underlying plumbing making this possible, the true HTTP moment of AI, is being driven by open protocols like Anthropic's MCP for vertical tool connection and Google's A2A for horizontal inter-agent communication.
That's the foundation.
But the reality on the ground is messy and expensive. Over 40% of these projects are going to fail spectacularly by 2027 because companies are blindly ignoring the coordination tax, the observability blind spots, and the sheer mathematically compounding complexity of governing autonomous swarms.
Exactly.
And while human coordination jobs are absolutely on the chopping block in the next 24 months, upskilling into roles like agent architect or agent boss is the clearest, most actionable path to survival.
Precisely. We are rapidly moving from a world where we manage static software applications to a world where we manage dynamic, unpredictable digital workforces.
Which leaves me with one final mind-bending thought for you to mull over as you audit your own job this week. We've spent this entire deep dive talking about multi-agent systems operating inside the safety of a single company's firewall.
Yeah.
But what happens when cross-organizational multi-agent interactions become the standard? Imagine a world, just a few years from now, where your company's purchasing agent swarm is autonomously negotiating in milliseconds with a vendor's sales agent swarm across the open internet using the A2A protocol. They haggle over price, they agree on liability terms, and they cryptographically sign a binding contract without a single human ever reading it.
It's coming.
How do we govern economic and legal accountability when two opaque, non-deterministic AI networks sign a legally binding contract without human intervention? When the swarms inevitably make $1 million mistake, who exactly goes to court?
It really raises a profound question about the future of legal liability, corporate trust, and the fundamental speed of business in a fully agentic economy.
Something to keep you up at night while you build your first crew AI swarm. If you want to stay ahead of this curve, understand the risks, and not become a 40% failure statistic, make sure to subscribe to Surviving AI on YouTube at Surviving AI Risk and wherever you get your deep dives. Thank you so much for joining us today. Stay curious, stay tactical, and we'll see you next time.